Number 23, the polygons are similar but not necessarily drawn to scale. Find the value of x. So what I did a little notation here just to make sure that we're comparing the corresponding pieces. So if I want to solve for x first, I'm going to make sure, that I have a corresponding values. So 16 is to 12 as x minus 1 is to 6. So now I'm going to cross multiply. So the value of x is 9. Number 24, are these triangles similar? How do you know? Automatically, I know that the three angles in a triangle add up to 180. So this missing measure here is 65. While 84.6 corresponds in both pictures, unfortunately, these angles are not congruent. So these cannot be similar. All angles must be congruent. Alrighty, 25. Plots of land between two roads are laid out according to the boundaries shown. So I want to find the value of x, which is this length here of plot 3. So I'm just setting up a proportion. 40 is to x as 48 is to 64. Or I could say 40 is to 48 as x is to 64. Regardless of which way you set that up, when you cross multiply, you're going to get the exact same thing. 48x is equal to 2,560. We'll divide both sides by 48 and we get 53.3 yards. All right. Number 26, a triangle has side lengths 24, 143, and 145. Is this a right triangle? So in order for something to be a right triangle, or the three measures, have to be able to be plugged into the Pythagorean theorem and give us a true statement. So when we do 24 squared plus 143 squared, does it equal 145 squared? Why do I know 145 goes in this spot? Because it has to be the hypotenuse. C is always the hypotenuse and your longest side. This does come out to an equivalent statement, so yes, it is a right triangle. Number 27, find the missing value to the nearest hundredth. So our missing value here in this little box, I just rewrote as x. So when I'm using trig and I'm solving for an angle, how do I enter that differently into the calculator? I want to find the inverse, so what angle has the cosine of 2/5. So second cosine, 2 over 5, and our answer to the nearest degree is 66 degrees. Alright, number 28, some more trig. Compared to our angle, the value of x is our opposite measure. 16 is the hypotenuse. Which trig function uses opposite and hypotenuse? Sine. So the sine of 22 is equal to the opposite measure, so x over 16. So I cross multiply. X is equal to the 16 times the sine of 22, which to the nearest tenth is 6.0. Number 29, again, a trig problem. So we know that the angle of depression is 5 degrees. We also know that these are alternate interior angles, so this angle would also be 5 degrees. X is my opposite value. 4,629 is my adjacent value. So which trig function uses opposite and adjacent? Tangent. So tangent is equal to x over 4,629. Cross multiply. X to the nearest meter is 405. Number 30. A highway makes an angle of 6 degrees with the horizontal. The angle is maintained for the horizontal distance of 5 miles. Draw and label a diagram. So here I have 6 degrees, 5, and x. Which trig function uses opposite and adjacent? Tangent. So we cross multiply, and my answer to the nearest hundredth is 0.53 meters. I had my class skip number 31. So we're going to move to 32. Given triangle QRS is congruent to TUV. So we have some different measures here, QS and TV. By the congruent statement, we should see that QS and TV are in the same position, meaning that these two measures are congruent. Oops, I wrote X, sorry. And now we also want to plug this in to find the values of QS and TV, which I know are congruent. So 3 times 2 is 6, plus 2 is 8.